Hello everyone. Actually, we are discussing previous year questions on soil water relationships. So today in this video we will discuss one more problem. So this question, so this question has appeared in 1999 and it is 1 mark question. So as usual, our procedure, we will read the question, take down the given data and just think what formula has to be used to tackle this problem. So same procedure I will follow. First I will read the given data. A soil sample in its natural state has mass of 2.290 kg. 2.290 kg. That means total mass he has given. Total mass of the soil 2.290 kg. 2.290 kg. Total mass he has given. And a volume of 1.15 into 10 to the power of minus 3 meter cube. So total volume is equal to 1.15 into 10 to the power of minus 3 meter cube. So total mass he has given and total volume also he has given. After that, after being oven dried, the mass of the sample is 2.035 kg. So after keeping in the oven, the water which is present in the soil will be evaporated, so mass will be decreased. So this will be the mass of oven dried soil. That means mass of solids 2.035 kg. 2.035 kg. And also what he has given, the specific gravity of the soil is 2.68. Specific gravity G suffix S is equal to 2.68 he has given. So what has been asked in the problem? The void ratio of the natural soil is. That means E we have to calculate. So if you carefully think, there is a relationship to calculate the void ratio from this given data. Okay. So that relationship will be gamma D is equal to Z gamma W by 1 plus E. Z gamma W by 1 plus E. So gamma D is nothing but the mass of solids to the total volume. Weight of solids to the total volume. Okay. So gamma D we can calculate, and gamma W we can consider in terms of kg per meter cube. Gamma W, unit weight of water, we can take 1000 kg per meter cube we can take, that we have already discussed. So first we will calculate gamma D, and then from there we can calculate E also we can calculate. So let us calculate. So gamma D is equal to mass of the solids by weight of the solids. Yes, weight of the solids to the total volume. So this weight is nothing but W is equal to mg, mass into this G by volume. So this mass, how much it is? 2.035. Here 2.035 is to be considered because we are calculating gamma D. So dry weight has to be considered. Okay. So 2.035 into 9.81 kg meter per second square is nothing but 1 Newton. So 1 Newton is equal to 1 kg meter per second square, because G is equal to 9.81 meter per second square and this is in kg. 1 Newton is equal to 1 kg meter per second square. So volume, how much he has given? Volume 1.15 into 10 to the power of minus 3. Volume, how much he has given? 1.15 into 10 to the power of minus 3 meter cube. 10 to the power of minus 3 meter cube. So let us calculate gamma d. 2.035 into 9.81. This is coming out to be 9.96 divided by 1.15 into 10 to the power of minus 3. So this is coming out to be 17359.434 Newton per meter cube. Newton per meter cube. If you convert it to kilonewtons, then it will be 17.359 kilonewton per meter cube. Kilonewton per meter cube. So gamma d we have calculated. Then z we know, gamma w we can consider, and e. So we can easily calculate. G how much? 2.68. Okay, 2.68. So gamma d 17.359 is equal to 2.68 into gamma w. He hasn't mentioned anything, like you can take 10 kilonewton per meter cube or nothing he has mentioned. So if nothing he has mentioned, we can consider 9.81 only. 9.81 kilonewton per meter cube divided by 1 plus e. 1 plus e. This is also in kilonewton per meter cube. I haven't mentioned the units, but you have to take care of the units also. So 1 plus e is equal to, I am just calculating, 2.68 into 9.81 divided by 17.359. So this is coming out to be 1.515. So therefore e is equal to 1.515 minus 1, that is 0.515, means 0.52. 0.52. So e we have calculated. So what we have done, based on the given data, total mass he has given, total volume he has given, and mass of the dry soil also he has given, and specific gravity of the soil also he has given. From there we have a relation. So from that we have calculated the void ratio of the natural soil. So 0.52, 0.4. From these options, this is very near, so this can be considered. So actually this is one way of solving or one way of tackling the question, and I'll tell you the other method of solving the same problem. Okay, this is method 1 actually. Okay, this is method 1. I'll tell you the other method which can be used to solve the same problem. So what we have calculated, we have to calculate E. So here we have used gamma d is equal to z gamma w by 1 plus e, and the other method, this will be like method 2. Okay, method 2. So gamma gs is equal to gamma s by gamma w. This method 2 is nothing but, what is the definition of void ratio? Volume of voids to the volume of solids. Volume of voids to the volume of solids. So total volume we know, and if we can able to calculate this volume of voids or volume of solids, then we can calculate. If we can able to calculate volume of voids, then obviously volume of solids we can get, because this is not just nothing but the deduction of total volume minus volume of solids. If you deduct total volume minus volume of solids, we will get volume of voids. If we deduct total volume minus volume of voids, we will get volume of solids. So I am just trying to find out one of these parameters, either volume of voids or volume of solids. Then obviously I can get the other parameter by deducting the calculated parameter. Okay, that anyway I am doing. I'm explaining very slowly so that you can cope up with my lecture. So GS is equal to 2.68 is equal to this gamma S, gamma W he hasn't mentioned anything, so we can take 9.81 kilonewton per kilonewton per meter cube. So from this gamma s is equal to how much? 2.68 into 9.81. so gamma s is coming out to be 26.290 kilonewton per meter cube. So if we calculate gamma s is equal to ws by vs that we know. So from here vs can be calculated. So how vs can be calculated? So this ws we know and gamma s also we know. Simply we can calculate vs. So vs, volume of solids, is equal to ws by gamma s. So this again, this weight of solids is equal to mass into this g, acceleration due to gravity. This is how much we have calculated: 26.290 kilonewton per meter cube. 26.290 kilonewton per meter cube. And also this mass of solids, how much he has given? 2.035. How much? 2.035 into 9.81. So this kg meter per second square will be Newton, divided by 26.290 into 10 cube we can write. Okay. So that Newton will be cancelled. The output will be in meter cube. So volume of solids is equal to 2.035 into 9.81 divided by 26.290 into 1000. So this volume of solids is coming around to be 7.593 into 10 power of minus 4 meter cube. So volume of solids we got. So volume of voids is equal to total volume minus volume of solids. So total volume, how much he has given? 1.15 into 10 to the power of minus 3. 1.15 into 10 to the power of minus 3. 1.15 into 10 to the power of minus 3 minus 7.593 into 10 to the power of minus 4. So this 1.15 into 10 to the power of minus 3 minus 7.593 into 10 to the power of minus 4. So how much it is coming around to be? 3.907 into 10 to the power of minus 4 meter cube. So volume of voids we have calculated, volume of solids also we have calculated. So void ratio is equal to volume of voids to the volume of solids. So volume of voids is nothing but 3.907 into 10 to the power of minus 4 divided by volume of solids 7.593 into 10 to the power of minus 4. So this 3.907 divided by 7.593. So this is coming around 0.5145. Okay. So this is actually method 2. So after reading the problem, whatever the method that comes to your mind, that you follow. It is not necessarily that you should follow the second method or you should follow the first method. So it depends upon that time. So what formula has to be used? So whatever the formula that comes into your mind, that you should use. It's not necessarily that method 1 or method 2. So ultimately our aim is to get the required parameter. Okay. So and in method 1 we have directly calculated gamma d, but you can also calculate this bulk unit weight also. That means total weight by total volume. we'll get bulk unit weight. So we can calculate water content. From there we can calculate gamma D from the relation gamma D is equal to gamma B by 1 plus W. So what I am going to say is, actually here we have directly calculated gamma D, but we can calculate gamma B also, total weight by total volume. Okay, total, from this total weight by total volume we can get gamma B. So gamma D is equal to gamma B by 1 plus W. So this W, how we can get? This total mass minus mass of solids divided by mass of solids. From there we can get the water content. So that way also you can calculate gamma D. So but just follow one method. So just for clarification only I have discussed all these two methods. Okay, thanks for watching my lecture. In the next video also we'll solve one more previous year question. Like that we'll solve one question by one question. So thanks for watching my lecture. If you feel the content is useful, please like my channel and subscribe as well. Thank you.